You heard the lady.
Yeah, I heard her. She's
Okay.
probably going to hold it against me too. All right, so you probably have a big screen up there where you can see everything, right? So I'm gonna share my PowerPoint show here. And take that into presentation mode. All right, so hopefully you guys can see my screen.
Yep.
All right. All right, so as I go through this, please feel free to jump in at any time. Some of you are far away from the microphone, so I may not hear you. So Tom, you may have to relay the question because it's just enough distance, enough of an echo that it's might be difficult for me to discern any question being asked. But as we go through, just fire away. This is going to be a very conversational kind of presentation. And as we go, if you have comments, questions, just fire away. So as I said, my presentation this evening is on relief valves, which Watts has been involved with for a very long time. And as part of this presentation, I could not help but at least get this in there real quick.
There you go.
So I'm currently an instructor with Watts. As I said, I started with them in 2007 as a product manager for hydronic products, relief valves, and a couple other, plumbing specialty items. It was a lot of fun. Got to develop some products. New product development's a lot of fun. Coming up with ideas, working with engineers to develop a product with marketing to market the item. So I had a couple of projects that I did that I had a lot of fun with, and Watts continues to sell those products to this day. Spent 5 years with Viga as a technical trainer. So that was really, I did training before, but that was really a deep immersion where I did it daily. And then I came back to Watts in 2018. I was hired to come back to be like an assistant product manager for the Radiant products. And about a year after that, they put me back in the exact same stuff I was managing in 2007. So I kind of did a full circle there. Since I turned 68 this year, they kind of, they say, hey, Jim, you thinking about retiring anytime soon? And, the magic words from corporate, right? So, yeah, okay, I get it. So I transitioned over into a training role, which is where I am now. My goal is to continue doing that for at least a few more years until I'm ready to walk away from it. But, I like staying busy, so I'm going to keep doing that for as long as I can. At one time, I was a third generation licensed master plumber on Long Island, really specialized in hot water heating systems, radiant systems, high-end boilers like Viessmann and Buderus, and outdoor reset systems and things like that. That's where a lot of my hands-on knowledge and experience came from. And as I said a little while ago, long ago in another galaxy, I was Doc Radiant on the wall. That was my handle there. So good old days, a lot of fun. So that's what I'm about. And what I hope to do here this evening is give you guys some insight on relief valves, their applications, the different kinds of relief valves, and certifications, things to be aware of, etc. So again, as we go through, feel free to fire away on any questions you may have. So in a broad sense, as we look at relief valves, they're used for many applications. And generally speaking, we can break relief valves down into two main categories. The first category is what we call safety relief valves. And safety relief valves prevent potentially catastrophic overpressure, over temperature conditions. So they really are a safety kind of device. And when we think of a safety device is, think of it as an airbag in the car, right? It's not something you want going off. It's actually something that should only come into play if there is something wrong with the system. right? There's an overpressure situation, over temperature situation that's not controlled. That's an unexpected event. Relief valve is a safety relief valve is supposed to address that. So within that category of safety relief valves, we have pressure only relief valves, and we have temperature and pressure relief valves. And then we have what are called control valves. Control relief valves are designed to discharge regularly as part of their normal operation. They are pressure only valves, and they can either be a positive pressure, such as a standard relief valve, or they can be a negative pressure like a vacuum relief valve. So those are control valves. And again, a safety valve is for safety purposes and not supposed to operate unless something is going wrong, whereas a control valve, a control relief valve, will operate normally. It's designed to function working on a pretty regular basis. So those are the broad applications. Within the safety relief valve category, safety relief valves, there are testing agencies and listings that safety relief valves must be listed to, or at least some of them. So one of them is ASME Section 4, which I'm sure all you are aware of. ASME Section 4 deals with boilers and pressure vessels. So basically, any relief valve that goes on a boiler or a Section 4 pressure vessel needs to be built to, designed to, and meet ASME Section 4 requirements. So that's ASME Section 4. There's also the CSA, Canadian Standards Association, ANSI Z2122. And that's a rating that is used both on ASME, temperature and pressure relief valves, and non-ASME pressure relief valves. We're going to talk about exactly what that is, what those ratings are. And then another listing is Underwriters Laboratory and FM for fire protection systems. So Watts has a relief valve. A couple of relief valves are intended for fire protection systems to protect those systems from overpressure situations. So, again, we have ASME, the American Society of Mechanical Engineers. We have CSA, Canadian Standards Association, NB, National Board of Boilers and Pressure Vessel Inspectors, simply referred to as National Board. Their role in this is they are an independent lab that tests and verify products that must meet the ASME standards, and especially Section 4. So you'll see the National Board logo, you'll see the ASME logo, you'll see the CSA logo, and those logos will probably be a little hard to see, but those logos appear on the plates of relief valves. And we'll discuss those a little bit more. So within the ASME Section 4 safety relief valves, these are boiler relief valves for pressure vessels. So ASME Section 4 provides requirements for design, fabrication, installation, and inspection of steam heating, hot water supply boilers, and potable water heaters intended for low pressure service that are directly fired by oil, gas, electricity, coal, or other solid or liquid fuels. So that's a kind of the definition of what Section 4 is. It also contains appendices which cover approval of new material, methods of checking safety valve and safety relief valve capacity, examples of methods of checking safety valve and safety relief valve capacity. And finally, the ASME valves are tested and certified by the National Board. So before we can market, this is an XL40, an ASME rated Section 4 T&P relief valve. Before these can be sold, they have to go through testing at the National Board and pass a variety of tests based on the certification, the ASME certification that we're going to. So here's a first group of what we would call Section 4 relief valves again for boilers, and it can either be hot water or steam. You'll see the 315 there. That's a steam relief valve. The 335 and 174 and 374 are for water applications. Some of these valves also can be made in lead-free construction. So for example, the 174 is available as a lead-free model. That would be for a hot water heating boiler, not for space heating, but for potable heating, potable water heating. The next group that we have, the 740, is our largest relief valve. It goes up to 2-inch. I don't have the ratings in front of me. It go up to like 3 million BTUs or something. And we'll discuss the ratings in a bit. The 415 is the big brother to the 315. That's a relief valve for steam boilers. And then the 375 is sort of like a big brother to the 335 for hot water boilers. The 335, by the way, that you see on the screen is the typical relief valve that's supplied with a boiler. If you buy a residential boiler, it's going to be a Watts 335 or a competitor equivalent. So that's primarily an OEM product. And really we sell the 174s, the 374s, and the 740s mostly through wholesale. We then get into what we call ASME rated relief valves. These are pressure only relief valves. These are not Section 4. These are typically used in applications like a tankless water heater. And you'll see different models there. There's a 3L, there's a LF3L, and the LF4L. LF meaning lead-free. This is simply the alloy that the body's made out of. And these also are national board tested, but not to the Section 4 standard. And they carry a CSA rating, which we're going to talk about exactly what that CSA rating is and how it differs from an ASME BTU rating. You'll always see the ASME rating is a much higher number than the CSA rating. There's a reason for that, which we'll get to in a little bit. And then we have valves that are not ASME listed, but are CSA listed. And this is really the same thing. The 53L is really the same thing as a 3L, except it's a 1/2-inch tapping. And this particular valve does not have an ASME rating, but it could be used like on a solar storage tanks, things like that. So, different valves for different applications, depending on what the requirement is, which will be based on the application. Then we have UL and FM approved valves. This is a valve, our latest valve for fire protection systems. One of the trends, I don't know if any of you guys are involved with fire protection systems, but one of the trends in fire protection is using higher pressure. So it used to be that a 175 PSI relief valve was kind of the setting that was used on all commercial fire protection systems. And of course, in the quest to make fire protection systems easier, faster to install, and less expensive, what the fire protection industry is moving towards is higher pressure. So if we go from 150 PSI to 275 PSI, we can deliver the same GPM to a sprinkler head with a smaller diameter pipe than we can with a larger diameter pipe. So that's the trend, is to reduce the cost of installation of fire protection systems. And one way to deliver the correct and specified amount of volume in gallons per minute to a sprinkler head with a smaller diameter pipe is to use higher pressure. So this valve, or valve that we had, that the old version of this valve would easily pass test at 175. It kind of hit or miss at 225, wouldn't pass the 300. The valve just was not designed to work properly at that high pressure level. So this valve is unique in that the spring works and all the mechanical linkage, et cetera, is external. It's underneath that plastic cover that looks like a fire truck. And this valve was specifically designed to be able to pass testing at 300 PSI, which it does. And it also has an additional feature to be able to lock it out. In other words, prevent the valve from actually opening, and that's by lifting one of those tabs and inserting an Allen key. So if a fire protection system needs to be tested at higher pressure, they don't have to remove the relief valve or put a plug in it. They can just, put this in lockout mode and do the same thing. So it adds some convenience on that level as well. So that's a fire protection relief valve, and again, UL and FM listed. And those tests are pretty rigorous. They're pretty stingy and pretty strict on things, approvals and features of the valve, and took a couple of passes to get UL happy with this valve, but we finally got there. We then have what we call a general purpose relief valve. And these valves generally don't have any listings, don't have any certifications. And these are just used for general relief, pressure relief application. It can be water, it can be oil, it can be air. What we're going to talk about in a little bit with T&P relief valves is the need to protect a T&P relief valve from thermal expansion, which we're going to talk about. And typically the way that's done is with a expansion tank, a potable water expansion tank. Another way to do it is with a secondary relief valve that we would install somewhere in the system on the cold line, and where the T&P is set to go off at 150. And one thing to know about pressure relief valves is that when you have a slow buildup of pressure, most of these valves just don't pop open and put 5 gallons of water on the floor in a second. They dribble. And what happens is at about 10% under the rating, the disc just starts to lift off the seat, and you start to get a little bit of a drip. And as we'll discuss in a little while, that's not a good thing for a safety valve. And it's really, really, I think, in the discussion we'll have here this evening, I think this is probably the most important point I need to convey, and I will be doing so a little bit later in the presentation. But what we can do is we can take where that 100 XL relief valve that's set to go up at 150 PSI will start dribbling at around 10% or around 135 PSI. We'll take one of these relief valves set for 110, 120, somewhere in there, even 100, so that this relief valve will pop open instead of going through the safety valve. It's also should be noted that the code in most areas limit plumbing pressure to 80 PSI. So even this valve set to 100 PSI will serve that role. So these are general purpose. The 53 that you see, that's set at the factory. It's available in different pressure sets. And then there's the 530C. It says calibrated pressure relief valve. Yeah, it's calibrated. It's as calibrated as it can be. But again, for a non-ASME, non-CSA, for a non-critical, non-rated device, it serves the purpose. So, within the pressure relief valve world, that's kind of a broad overview of what's available and what their applications are. And finally, we have vacuum relief valves. And vacuum relief valves work exactly as they say. If we develop negative pressure in the piping underneath the valve, it lets air in. And these are used primarily on water heaters. You can imagine, somebody servicing a water heater, and they hook up their transfer pump to drain the tank out real quick, and they don't break the vacuum somewhere, right? They don't open a faucet, something like that, and the vacuum relief valve protects the tank from damage. Like back in the day, I used to install a lot of Amtrol indirect fired water heaters. In fact, I have one in my own house. I think very highly of them to this day. They work well, but they have a polyethylene liner. And if you don't break the vacuum, you actually collapse the polyethylene liner inside the tank, and it ruins the tank. So vacuum relief valves are mandated by code in some areas for installation on water heaters typically. So it is another form of relief valve, even though it's a vacuum relief valve as opposed to a pressure relief valve. Any questions so far?
Somebody steam cleaned a railroad tank car and then went to lunch, but he left the lid closed. So when the steam condensed, the atmospheric pressure crushed and ruined the tank top. Would have been nice if they had a vacuum relief in there. But I don't
Yeah.
think
Any way to get that microphone closer? It sounds like I'm listening to you through a long tunnel. I can barely hear you.
Yeah. Oh, it's over there, Phil. Go by the camera.
All right, somebody steam cleaned a tank, railroad tank car, and then let the lid close when he went to lunch. When he came back, they completely collapsed. The atmospheric pressure crushed.
Yeah. And the steam condensed and caused a vacuum?
Yes,
Yeah, okay, got it. Yeah, so this kind of relief valve would prevent that kind of thing. But I think in this case, the steam is not normally present in that tank that was cleaned. It was more of a, more of a maintenance kind of an occurrence, it sounds like.
yes.
Yeah, so a vacuum relief valve would certainly would have addressed that problem, no doubt about it, because as the air pressure goes higher on the outside than on the inlet of that relief valve, of that vacuum relief valve, the valve's going to open and equalize the pressure. So you would never get a vacuum buildup anywhere. So a vacuum relief valve would have solved that problem. And that's an interesting case. And a lot of people don't realize that as steam condenses, it can pull a vacuum like that. It drop the atmospheric pressure inside of a sealed tank. So probably the moral of the story is leave the lid open, right? Or leave something open so that you don't develop a vacuum. But a lot of water heater manufacturers and some local code require these vacuum relief valves on water heaters. And vacuum relief valves are also obviously part of backflow devices, right, to prevent siphoning, things like that. So that's the general application for them. They really don't have any certifications, they're not ASME or anything like that. They're simply lead-free or not lead-free. And I have an interesting conversation about the standard alloy, as we'll call it, and a lead-free alloy when it comes to TMP valves, right? Because technically anything that's in contact with potable water is supposed to have less than 0.25, less of 1/4% of lead content. But yet, standard alloy relief valves are installed by Rheem, A.O. Smith, and others in their tanks from the factory. We'll talk about that in a minute, why that is and how that can happen. Then we move kind of into the control valve situation. And in a way, the 53 and the 530, they're not really control valves, but they're kind of being used to control a regularly occurring a situation, thermal expansion, which again, we'll talk about a little bit more in just a bit. These valves are typically used for to bypass the head pressure of a pump that's operating continuously. So you've probably seen these kinds of valves maybe on a radiant manifold, right? So you don't deadhead a pump. And basically these valves are designed to function that if you have a pump that's operating continuously, this valve is basically installed at the outlet, at the discharge port, and is piped back around to the suction port on the discharge, so that if the pump curve gets too high up on the head pressure to prevent the pump from deadheading, this will open and just allow some bypass, some flow through the pump to prevent the deadheading, cavitation, etc., which can damage pumps. So these are control valves. So They only represent a small part of the relief valve offering, but these are a classic definition of a control relief valve that are intended to operate on a regular basis. So the series BP30 is a diaphragm operated valve, and the 5300 is a pop action, poppet type of design. They function the same way. They serve the same purpose. So those are pressure relief valves. And again, we have pressure relief valve for Section 4 boilers, and then all the other applications that we talked about. Tankless water heaters, interesting conversation we had there. Do you actually even need a relief valve on a tankless water heater? And interestingly, when you buy a boiler, I'm thinking this residential boiler now, just so we all have the same picture painted in our mind. When you buy a residential boiler, it comes with a relief valve. The relief valve may already be installed on the boiler. If it's a knockdown, maybe you have to install it, right? But they come with a relief valve. For those of you who install tankless water heaters, unless you get the accessory isolation kit, they don't come with a relief valve. Think about that. How can the manufacturers of a tankless water heater sell their product without a relief valve? But when you think about the operation of a tankless water heater, as compared to a boiler or a water heater that can fire with no flow, right? Tankless water heater can only fire if someone opens a faucet somewhere. And having worked with tankless water heater manufacturers in my role as a product manager, we offer a tankless water heater service valve kits. We sell those kits to Navian, Noritz, A.O. Smith. So we have a lot of discussion with tankless water heater manufacturers. And as you know, a tankless water heater has a flow switch. So the unit won't fire unless we make the flow switch, right? It's a turbine, a little turbine wheel. You open a faucet, turbine wheel spins, it fires the boiler. One of the interesting questions I asked the manufacturers, I said, does the flow switch ever fail? Yeah, occasionally a flow switch will fail. Does it ever fail in the closed position? No. When they fail, the unit just won't fire. So when you think about it, the only way and the only time a tankless water heater fires is when you have a faucet open. So it's like having a relief valve on there and the relief valve is open. And as soon as the valve closes, as soon as the faucet closes, it stops. So it's a road that someday I'll go down in greater discussion with somebody, I don't know who, but why do we need relief valves on tankless water heaters when they can't possibly fire under no flow conditions? But still, Watts and the other manufacturers of tankless water heater valve kits supply the kits with a valve like we saw previously, like the 3L. It's an ASME rated, CSA listed pressure relief valve, not a Section 4, but it's ASME tested and listed. And we supply those with the tankless water heater valve kits. I'll just mention this now, and someone remind me when we get about 15 minutes further in Michigan. I don't know if any of you guys do any work in Michigan, but there are places in Michigan where the local inspector requires a T&P valve on a tankless water heater. And when the rep tells me about this, I just scratch my head and I say, these guys don't even know what the purpose of a T&P valve is and how it functions. It's not going to do anything on a tankless water heater. But anyway, a lot of times we have local code overriding national code, and I'll go as far as to say, maybe overriding common sense and overriding, true technical knowledge. And they ask for things that really don't make sense, but, since they're the boss of the town, and you got to make the installation comply with their requirements, and okay, now we put in the TMP valve and kind of laugh about it, but there's this kind of stuff that goes on as well. All right. So now we're going to move into TNP valves, where we basically take a pressure relief valve that we discussed, and what you see hanging out of the bottom of these things is a thermostatic element. And the way that thermostatic element is made, think of it as a closed cylinder. It's closed on the bottom. It's hollow on the inside. The thermostat is filled with a special wax material that when it hits 212 degrees, it rapidly expands. And it's a special formulation of wax that does it at that temperature. And at the top of that column of wax is basically a piston. And the piston's held in place, it's crimped on the top, and the piston is sealed so that when the wax expands, the piston pushes up with great force. In fact, in a test jig, when that thermostatic element is heated at 212 degrees, that piston, the pin that lifts the valve, that lifts the disc off the seat, has enough power that it can pierce a penny. That's how powerful it is. And when that thermostatic element hits the expansion point, it's immediate, it's rapid. So one of the things about TNP valves about discharge, right? You may get a call, hey, the TNP valve is going off, right? If the TNP valve is just dribbling, it's due to pressure, because the pressure typically isn't going to happen instantaneously to a very high pressure. It's going to build up incrementally, and it's going to slowly lift the disc off the seat, and you're going to get a little bit of a dribble out of the discharge. When you get a big discharge, that means a thermostatic element tripped, and that takes a real catastrophic failure of the control system. That basically means the aquastat failed in the closed position, and that son of a bitch is just running. And we're going to get into a section here that goes into great detail about the unbelievable hazard that represents, far more than an overpressurized water that's not superheated. So so these are ASME Section 4 TNP relief valves, and they are intended for what we typically call commercial or ASME water heaters. Anybody know where the line is when we go from a non-ASME to an ASME / commercial water heater? Anybody know where that line is?
199,000 BTUs.
That's it. Or any 200,000 BTUs or more, or 120 gallons or more. So it's both input and also storage capacity. So you exceed either one of those two, you're now into an ASME Section 4 device, right? That needs to be tested and listed by national board. And that's why you see commercial water heaters, your typical glass line tank commercial water heaters, they 119 gallons, right? As soon as you get to more than 100, more than 120 or more, now you get into these, they look like a, like a submarine, right? That built the welded steel, the real heavy duty. Those are ASME water heaters. So these particular water heater valves are 40, 140, 240, 340. These are a series of TNP valves that are intended for commercial water heaters, or specifically, technically, ASME Section 4 water heaters. From there, we have relief valves that are rated, that are intended for water heaters with less than 200,000 BTUs of input, or less than 120 gallons of storage, which is a typical residential water heater. And in the watts line, you'll see that we have a series of valves, the smallest being the 1L. The 1L has a 1/2 inch tapping, And that's rated for water heaters up to 15,000 BTUs. Again, it has to be less than 120 gallons, but up to 15,000 BTUs. The 10L is rated up to 80, and the 100XL is rated up to 105. If we have a water heater that has greater than 105,000 BTU input, we're then going to, one of the previous valves we're going to be going to probably a 40 to get these rating. Even though that's an ASME section 4 commercial relief valve, once you go beyond 105,000 BTUs of input, you need to go to a valve that is rated for that capacity. We're going to talk about what that capacity is. We're getting there. The 100XL is offered, as you can see on the right there, is offered in different shank lengths, and that only has to do with the thickness of the insulation on the water heater. With water heaters, with the insulation growing thicker and thicker for energy conservation, the shank has to be longer, right, to reach down through the insulation to engage the tapping on the tank. And obviously the thermostat probe has to be long enough to get into the top of the tank and the actual tank itself. And again, we're getting into a section here where a lot of the focus of tonight's discussion will be. So these are your typical residential TMP, non-ASME water heater application TMP valves. Okay, this to me, gentlemen, is kind of a critical discussion for my presentation this evening, and I think is probably something that if I can convey this well, you probably are all aware of this already, but it's worth discussing again and really getting our brains wrapped around this and understanding what this is all about. So a TMP valve is by far the most critical safety device on a water heater. And the reason for that is that when water boils and we heat it beyond 212 degrees, we are beginning to store energy in that water. It becomes what's called superheated. And Watts had a video they put out long ago, explosion danger lurks. And it showed how a water heater that is running away, that's not shutting off, and if it does not have a functioning relief valve, or maybe no relief valve at all, or a relief valve that no longer functions properly, either due to a variety of situations, as you superheat that water, it is collecting latent energy. And when the tank finally bursts, that superheated water flashes into steam and creates an explosion. It will literally blow the wall out of a building and kill the occupants. So as you can read in there, TMP valves, when installed properly, prevent high water temperatures, which can lead to an explosion. So we'll talk about that a little bit more to really understand what's going on. So you can read what's on the slide. I would suggest you read this, the boiling points of water. As we know, as we put water under pressure, we raise the boiling point, right? So, the cooling systems in our cars, they may have a 15-pound cap, so we can run the thing, we can run our coolant up to 240 degrees before it goes into steam. So as we go above 212 degrees, the more pressure we put that water under, the hotter that water can get. It's called superheated, and boils under atmospheric conditions at 212 degrees. And we see here water supply pressure to the water heater at 90 PSI. The boiling point is 331 degrees. Like, holy crap, right? And at only 50 PSI, water flashes into steam and boils at 297 degrees. The energy, if released by a water heater rupture, can equal more than 1 pound of dynamite. That's no shit. that's like some serious stuff. So interestingly, Mythbusters, if you've never seen the episode, it's kind of a hoot. You gotta watch it. I'd recommend if you can find it on YouTube when they do the water heater test. They were able to take a 30-gallon water heater and they launched the thing 300 feet up in the air. And the joke was, we should have contacted the FAA because now we're like in, public airplane space. That water heater went 300 feet up in the air. And again, the explosive capability of superheated water flashing into steam is unbelievable. So as you can imagine, Watts is a long time manufacturer of T&P valves, has seen its share of screw ups that have resulted in catastrophe. And that's why there's a whole bunch of legalese associated with these valves, because this device is preventing what you're seeing on the screen from happening. So we had one case, and it goes back about 20 or so years ago. It was a private school in New England, and the janitor, the handyman, was replacing a leaking water heater. And they got the new water heater in. The relief valve tapping was on the top, but the new tank was taller. They wanted a little more water, hot water heating capacity, so they got a bigger water heater. And the tapping for the relief valve was on the top. Had a new relief valve, came with a new relief valve, but he couldn't get the thermostat probe was too long and he couldn't get it into the tapping. He cut the thermostat, took a hacksaw and cut the thermostat down until he could get it in to the tank. No shit. This is actually a true story. And of course, now the thermostat doesn't work, right? When that wax expanded, it just shot right into the water. There was a problem, and that water heater exploded and it killed kids. So that was a legal entanglement that was entirely the school and their janitor's fault. Obviously, it was not a manufacturing defect of the relief valve, but Watts, as a community player, I think they contributed to the payment, to the settlement of that. But it's serious stuff, and we really need to be cognizant of these things. And just like the airbags in our car, we want to make sure they work, and we want to make sure we're not doing anything that's going to compromise the function of these valves, because bad things happen if circumstances line up a certain way. So watch the Mythbusters episode on this. It's a hoot. It's really a hoot, as Mythbusters usually is. So how does a T&P valve work? This kind of goes back to when I was talking about the inspector wanting a T&P valve on a tankless water heater. Not making any sense. So the way a T&P valve is supposed to work is, let's say we have a situation where the aquastat fails, right? The aquastat fails in a closed position and the burner continues to fire. And we're heating that water. And what happens is, when the water at the very top of the tank hits 212 degrees, right? Of course, it's going to be a little lower down here because you get some stratification. But when that temperature reaches 212 degrees at the top of the tank, this relief valve is going to open, and it's going to open fast, and it's going to stay open until that thermostat drops below 212 degrees. So it usually results in a fairly significant amount of water being discharged. But in this process, what's happening is, as hot water is discharging out at the top of the tank, it's being replaced by cold water. And that cold water cools down the heater. So even if that burner continues to fire unnoticed, we will never allow the water to become superheated and to have the potential of an explosion. So this is a key thing to think about, is that function is introducing cold water into the tank to prevent that volume of water from becoming superheated and causing a potential explosion. So a couple of things here is that it's important that, number one, you don't cut off the thermostat, like you don't do that. And that number two, that we make sure that the thermostat, the actual probe is in the tank itself, right? In that body of water in the tank itself. Some of the bad installations you might see is a TMP valve with, 2 feet of pipe before it gets to the water heater. That's no good. This needs to be in the tank to be able to sense that temperature. Because if we have this thing mounted on a piece of pipe 2 feet above, you know what? That tank may fail long before this thermostat actually senses the temperature that far away and gets cold water in there to cool the thing down. So that's the function of the TMP valve, why it's critical, and how mechanically how it works to prevent the superheating of water in a water heater. Now, ratings. You will see on a typical TMP valve, probably hard to see here. Let's see if I can get it to focus. But you're going to see two ratings. You're going to see a CSA rating on the top, and you're going to see an ASME rating on the bottom. So the CSA rating for this particular valve is 205,000 BTUs. The National Border ASME rating is 1,438,000 BTUs. What is the huge difference between those two? And the way relief valves are measured, the way they're rated, is they are attached to a tank of steam. And on the CSA test, the tank of steam is at 15 PSI, 15 PSI. And what happens is the valve opens with 15 PSI of steam on the inlet. They collect the steam, it condenses, and that pounds of water represents the discharge capacity. CSA is always at 15 PSI. ASME rating, this valve is rated for 150 PSI, so they do the same test for ASME only at 150 PSI. So obviously you're going to flow a hell of a lot more steam through this valve at 150 PSI than you are at 15 PSI. So the takeaway is that when we select a TMP valve for the water heater, it's always the CSA rating that we use because that's the most realistic condition that we might encounter in a water heater. And, most water heaters, when they hit 150 PSI, we're already well into dynamite range. So it's a CSA rating, as you see there, CSA rating of 105. Even though the ASME rating is 200,000, it's a CSA rating we use for selecting TMP valves. So here's another part of what we need to think about. And this has to do with a situation that I would be willing to bet every one of you have seen this. And it has to do with the problem of thermal expansion in a plumbing system. So thermal expansion happens when, as the water is heated up, and there's no place for the expanding water to go because water is not compressible. An example of how this situation might arise is that we have a home that was on a well, on a well system, right? So we have a pump, whether it's a submersible or it's a jet pump, and we have a well tank. And the well tank is an air cushion that the pump presses water, pressurizes against. We set our high-low switch that pressurizes that tank. That tank serves as an expansion tank. So as the water heater heats up, if there are no faucets open anywhere inside the building, the pressure backs up into the well tank. So we never get to a point where the TMP valve starts to open, starts to dribble. When we are connected to a public water supply, we pretty much have the same situation. We have the main coming in. The water pressure, of course, comes from a tower, right? That's located somewhere not too far away at a much higher elevation. So as the water heats in that tank, it basically, quite literally, pushes water back up into the tank, up into that tower. The problem arises is when we put a check valve, like a backflow device, on the main coming in, or we somehow end up with a check valve between our well tank and our water heater. So now we have bookends. Now that water heater is locked in, and as the water expands, it has no place to go. So the only thing that can happen is that the pressure slowly builds up. And as our pressure slowly builds up, and again, this is just normal heating, right? Just normal operation of the water heater. And the further you draw down the water heater in terms of its capacity, and then close all your faucets without a way to deal with the thermal expansion, the greater amount of thermal expansion you might have. With thermal expansion in this situation, as soon as someone opens a hot water faucet somewhere, you're done. The pressure is relieved. But if you think about the situation where you don't have an expansion tank, or you have a situation where there's no accommodation for thermal expansion, everyone takes a shower, they do a load of laundry, they all go to bed, right? No one's using hot water for the rest of the night. And here's the water heater, it's recovering from this extreme use of hot water, and we're building up thermal expansion. As the thermal expansion builds up, the relief valve starts to dribble. And that dribble may or may not be noticed because it's not a lot. It's just a dribble. And it's commonly seen as staining at the bottom of the discharge tube. Or it might be seen as a little bit of a wet spot under the water heater, under the discharge point of the pipe. And someone will see it and no, it doesn't look like a big deal. Well, it is a big deal, because what happens is over a period of time, and especially in hard water conditions, if you look at the photo, what happens is we start getting a buildup of mineral deposits on the outlet of the valve. In other words, we are now starting to compromise the operation of this valve. It is now probably not going to pass the same amount of steam through that CSA test. And we may even have a situation where eventually it won't even open, right? We end up with a failed relief valve due to thermal expansion. This is a major consideration, and it's a major problem. And I would behoove all of you to that when you're installing a water heater, or if you're in a home that has a water heater, that you look for these telltale signs of the relief valve dribbling. And because it could be a thermal expansion problem. And in a worst case scenario, we could end up with a compromised relief valve that doesn't work when it's supposed to. And as we saw, that could result in some pretty significant problems. So first of all, how do we detect a thermal expansion problem? So we have a series of products here. The first one is the IWTG gauge. And you'll see the red needle on there. That's a telltale needle. And basically you just kind of set it to 0, and you screw this on to like a lawn faucet or to a hose bib somewhere, wash machine, whatever. And you screw this on, you open a valve and you leave it open. And you let the people do what they normally do. In a normal situation, let's say there's street pressure coming in is 60 PSI. We wouldn't expect to see, more than 65 or 70 PSI after a couple of days of use, because as the needle goes up, it pushes the red needle up, and as it falls, the red needle stays where it was pushed up to its maximum point. So if you come back and all of a sudden you see that red needle is like, over 100 or, like over 120, you got a thermal expansion problem, and you got to deal with it, because if you don't deal with it, it's going to lead to other problems. And it's not only with the relief valve, it's excess pressure in the plumbing system, which can cause other problems. So the ideal way to deal with it is with an expansion tank, and one that's intended for potable water application. So in the Watt series, it's the PLT series. and they're made in a variety of sizes. Usually the smallest one, either the 5 or the PLT5 will do the job. If you have a 30 or 40 gallon water heater, it's usually enough. If you have larger water heaters, we have models that will go all the way up to a PLT 20. So, there are larger models available. There's a 5, there's a 12, there's a 20. But usually the 5 will do it. If in doubt, you can always just put in a 12. The other way to go about dealing with the thermal expansion, this is actually fairly popular in the southern tier states where they don't experience freezing conditions, is they will use the 53 or the 530C as a secondary relief valve, set at say 100 PSI. So as you get thermal expansion, they pipe the thing like, to the garden on the outside because they don't have freezing conditions, and that relieves the thermal expansion. The whole idea is to protect the TMP valve from dribbling due to thermal expansion. TMP valve is not an operational valve. It's a safety valve, and it should not be allowed to deal with consistent and ongoing thermal expansion issues. So with that, there are some upcoming changes to the International Mechanical Code. It looks like this is going to be included in the 2024 edition. It's on track to do so. It's not engraved in stone yet, but it's a near certainty because of where we are in that process. It's a very long process. It takes a couple of years. Changes are proposed. It goes past the technical committee. It gets open to public comment. Then there's a final vote taken on it. This is all the way up to the final vote. And based on what I heard at the initial technical committee presentation, this is going to happen with the IMC. So in the IMC, and the UMC has a similar section. There is a section in the IMC at section 1006.6 that has to do with the piping of the discharge of a relief valve. A lot of it's common sense. We don't plug it. We don't put a 3/4 by 1/4 inch compression bushing in there and run a piece of 1/4 inch copper to someplace. This code explains exactly what the requirements are. So can't be directly connected to a draining system, needs to discharge through an air break in the same room as the appliance. So basically you keep 6 inches above the floor, cannot be reduced in diameter. You can't have a trap, a couple of elbows and make a trap. You can only have so many elbows in there. But 0.7 is the one where there's looks like there's going to be a change. And 0.7, as you can see, is discharge to a termination point that is readily observable by the building occupants. That's already there. It's been there for a long time. And if you think about it, it makes sense. If we see a relief valve discharging, it's a safety relief valve, there's a problem. It's just like the check engine light coming on in your car. Don't be like me and put a piece of black electrical tape over it. That's not good. When the check engine light goes on, you probably should look into it. If you get a discharge from a safety relief valve, there is a problem. It needs to be investigated. So in the code, they say, hey, we want people to be able to see if there is a discharge from that relief valve, either water on the floor, the telltale signs of discharge of, some mold, water spots, etc., that you can see that there's been a discharge going on. That's been in the code. The situation arises where we have a mechanical room or a situation where you cannot visibly see the discharge, right? It's buried somewhere in the back. It's not readily observable to someone who's, as they go about their normal activity, they, on a day-to-day basis, they would notice the discharge happening. And what the code is going to say is that the discharge termination point is not readily observable. Discharge monitoring is going to be required. In other words, if you can't see it, we need some other means to tell us if there's a problem, just like the check engine light, right? Or your tire pressure monitoring system in your car. If you're not checking the air pressure in the tires manually with an air pressure gauge, now you got a gauge on the dash to say, hey, the air pressure is low, right? Same kind of thing. So this looks like it's going to be as part of the 2024 IMC code. It's a change that's coming. And it has to do, it really has to do with everything that the conversation has led up to, is the fact that the discharge of its safety relief valve is not a good thing. If it does happen, we want to know if it is happening so that we can then address the reason why it's happening to prevent larger problems. So Watts is in response to this code. This is new product development. We are working on some concepts that will allow us to detect the discharge of a relief valve. And it's basically a sensor. One version might be a sensor that clamps onto the discharge pipe. There's a fitting that screws into the discharge port. There's the sensor circuitry clamps onto it. If it detects that dribble of water going through it, it's going to send a signal, right? It could go Wi-Fi. It could go to, go to your smartphone. Hey, your relief valve's dribbling. It could go to a building automation system, etc. The step beyond that would be integrating a sensor directly into the relief valve body itself. The first option that you see there, the sensor on a discharge, is like a non-invasive way of being able to do it and to be able to retrofit on an existing relief valve. But moving forward, we could very well see relief valves that actually have that sensor built in to the discharge, to the valve itself. That will then, communicate, through some means that a discharge is happening. Rheem, for example, now integrates into one of their lines of water heaters a leak detection system. Watts has what's called the water detector shutoff. We've had that since 2007. It was a product that I immediately got involved with right after its launch, which is basically a pad that sits under the tank. And if a leak happens, if the tank starts to leak, we shut off the water supply to the tank and we shut off the power supply so that the burner can't fire. So we shut them both off at the same time. We had a patent on that, and it looks like what Rheem has done is they've taken that same concept and they have integrated it into a line of their water heaters. It's leak guard, something like that. So, but in their installation instructions, it's clear that the discharge of the pipe, the sensor that they're using, is built right into the water heater. It's in the jacket. It's at the bottom of the tank, but it's inside the jacket. So it's not going to detect a relief valve discharge. So depending on whether the code actually goes through, which we're confident it will, and the local adoption of that code, we could very well see that relief valves equipped with that come on water heaters will have this capability built into them. So some interesting things happening in regards. It's interesting in that it all deals with the unintended consequences of relief valve discharge. So it's something that maybe a lot of us never gave much thought to, but it is something that is a really important conversation. The last thing I wanted to cover, I see my hour is just about up, is before I had mentioned that we have leaded, what I call standard alloy relief valves, and lead-free TMP relief valves, TMP specifically. So we sell volume-wise the majority of our relief valves to OEM customers, Rheem, A.O. Smith, etc. They are, by the rules, allowed to use a standard alloy relief valve because they install it in a tank. And if any of you have ever tried to remove a relief valve, a TMP relief valve installed in a tank, it's like they have an 800-pound gorilla on a 4-foot wrench putting those things in. So because the calculation is based on what's called wetted area, when the valve is installed in a tank, the tank itself is part of the wetted area. So now we can use a standard alloy relief valve, but because the wetted area of that relief valve is so small compared to the entire wetted area of the device, that a standard alloy is acceptable. And this was a big to-do back in 2011 when the lead-free law took took effect. At first, it had to be all lead-free relief valves, and then they finally came around and said, nah, we don't have to do that. Use a regular relief valve, a regular alloy relief valve on a water heater because of that wetted surface calculation. So we still offer lead-free relief valves, and kind of going all the way back around to Michigan and the inspector wanting a T&P valve on a tankless water heater. Hopefully some of the points that I discussed here this evening, you kind of say, huh, that doesn't make any sense. Why are you putting a T&P in a tankless water heater? Anyway, that's my shtick. Watts has a lot of learning opportunities. You can go online. We have e-courses. We do sessions like this evening. A lot of great training topics. I encourage you to log on, watts.com, take a look in the training section. There's a lot of good stuff in there. All kinds of stuff, right? Relief valves, backflow, all kinds of things are in there. So it's a good resource if you want to stay up to date on some of the latest things going on with codes and standards and product development. So that's it. I hope that pizza was good. Looks like it's all.
We left you a piece, Jimmy.
Looks like it's all finished.
Hey, I have a couple of questions for you.
Sure, shoot.
I don't know if this is true all over the country, but in Ohio, when we're doing boiler installs, you may get a boiler with the relief already installed, and it's typically out the side. Inspector comes in, looks at it, says, no, you can't do that. You have to install it vertically. So their concept is we pull it out, put a couple elbows on it, and install it out of the elbows. So, but they don't do that for water heaters, which puzzles me.
Right. So, yeah, there's some debate about that. The theory behind that is if you look at a closed loop hydronic heating system, and especially, most boilers are made of ferrous material. And you get a certain amount of sediment and sludge in there, especially if there's a slow leak somewhere and you're feeding fresh water in, on somewhat of a regular basis. You're introducing oxygen into that closed loop system, causing corrosion and the stuff, that flakes off, the sludge that's caused when ferrous metal corrodes. In a tight system that's not leaking, you fill it and all the dissolved gases are driven out of solution and vented out through the air separator as the water is heated, and the water basically becomes anaerobic and no further corrosion takes place. That's why we can use ferrous components in a closed loop system. But if you have any kind of situation where you have a leak or your system's been opened up a lot of times and you're introducing fresh water into that system, yeah, you know what, you might get some sludge in there. So the idea is that if we have a relief valve on the side, it's possible that as we look at, let's see if we can see this, but you can kind of see, here's the inlet, right? And you can kind of see the disc, the rivet that's holding the disc in place, right? So if this thing is horizontal like this, right? And let's say it's on the side of the boiler, right? It's possible that we might get some sludge buildup in there. But to a large degree, that sludge is never really going to harden like the deposits I showed you previously on the discharge port of the T&P. So when this valve opens, it's still going to open. It may not reseat though. It may continue to dribble. That's probably the main peril of any kind of sediment building up in there. If we have this thing vertically like this, obviously we greatly reduce the chance of any kind of sediment building up in the seat area and on the disc. So in that regard, yeah, it makes sense. But really, the only problem that occurs would be if you pop open the relief valve, or if the relief valve opens, that crap is going to get on the seat and the thing's going to sit there and dribble, which may not be a good situation either, because as it dribbles, you're now introducing fresh water into the system and you're causing more corrosion. So I will say personally that installing them vertically is preferable. If one is installed horizontally, I'm not necessarily losing sleep over it. But I do agree that installing them vertically is the preferred way to do it. So if an inspector is asking you to do that, I don't think that's unreasonable. Because the valve is better protected from any contamination inside the system when it's installed vertically.
Thank you, sir.
My pleasure.
All depends on what the inspector says, huh?
How's the pizza?
Ohio is cold.
Smells good. Pizza smell good.
That would be pretty wild, wouldn't it?
Smell
Wi-Fi
of it.
smells. Smell of it. You text your wife, hey, remember last night?
Thanks. All right, well, if you don't have any other questions, let me just go back to my original slide here where it has my contact info. You can see my email address down at the bottom. Feel free to reach out to me. If you have any questions about relief valves or really any of the watch products in general, hydronic products and relief valves are kind of my wheelhouse. But if you have questions about any of the other products, backflow, or ACVs, pressure reducing valves, etc., feel free to reach out to me. And if I don't have the answer, I know where I can go get it for you. So feel free to reach out to me at any time on it. Even if it's not a watch product, if it's just a general application question, happy to help you with that.
Thanks, Jeff. Do me a favor and shoot me your snail mail address, would you?
Yep. Tom, is that you?
Shoot me your snail mail address in the email, would you?
Got it. Will do. Will do.
Appreciate it. Have a great night.
Thank you, gentlemen. You as well. And thanks again for your time this evening. And again, if you have any questions, feel free to reach out. Tom, thank you for the opportunity. I appreciate the invite. Maybe we do it again sometime. And I'll send you an email with my contact info.
Appreciate it. Take care, Jay.
Looking forward
All
to it.
right, everyone. Have a great evening.
Bye now.
Take care.
Hey, Mark. You know they wrapped that van in 2 different colors? You guys were looking at all the bubble flake and the paint?
Yeah, it's not,